In this video, I want to explain why this property is true for when all the variables are real and all the expressions to calculate the values on the left and right hand sides are real. This specific property is true for the expressions and even the variables that are non-real but complex and defined, but that is beyond the scope of this video. Here's my outline for this video. So first I will explain why it works with positive integer exponents or counting number exponents, then why it works with positive rational exponents or positive exponents that can be written as a fraction, and then why it works with positive irrational exponents. Now note I do not have this for zero exponents or negative exponents. The definitions for zero exponents and negative exponents come from this property, and I explain why the definitions are what they are later in this set of videos. Let's talk about how we would simplify this if we did not know that property. Well, the definition of exponents is repeating multiplication, and so we had this, and then we simplify it out, and now we have 3 multiplied to itself 7 times, and so that'd be 3 to the 7th power, and so that'd be 3 to the 5 plus 2, and so we are adding exponents. And you can do likewise for variables with m and n as positive integers. But what about when you have positive rational exponents? Well, let v be equal to 3 to the 5/7 times 3 to the 2/3. Take both sides to the 21st power. This is a property about exponents, and I plan to explain it later in this set of videos, and let's use that. Now, I think a definition of a fraction exponent where the numerator is something other than 1 is this, and let's use that. Now, here's a property about exponents I plan to explain later in this set of videos. Let's use that property again. And now a to the 1 divided by d and a to the d, those are inverses. And so we just get a when we apply them together. And let's use that idea. And now we already know that this property works when m and n are integers. And now we take the 21st root on both sides. And now we use this property that I plan to explain later in this set of videos. And so we get that v is equal to 3 to the 5/7 plus 2/3. And so we're adding exponents in this case. And you can do likewise with variables. Now question, what if this step was irreversible? Well, that would mean that this expression would have to be negative. And so that means either that expression or that expression would have to be negative. And so that means a or a would have to be negative. And so that means that a is negative. Also, you need to have dg to be even. So that means that either d and or g has to be even. And remember that a has to be negative. And so that means that either a to the c over d or a to the f over g has to be not real. And now in this video, we're only talking about cases where all the expressions are real. Now this property is true for when you have some expressions that are not real but are complex and defined, but we're not talking about them in this video. What about if you have positive irrational exponents? Now 3 to the pi plus 4, if you punch it into your calculator, you get this. Now 3 cubed times 3 to the 4th power, you get this. And as you get closer and closer and closer to 3 to the pi times 3 to the 4th power, we get closer and closer and closer to 2555.086 and so on. And so that would make sense for 3 to the pi times 3 to the 4th power to be equal to 3 to the pi plus 4. And so we're adding exponents here. Thank you for watching this video. Here is the link for the playlist about the why behind for some properties of exponents.